Lesson 11.4 is on multiplying and dividing rational expressions. In this video, you will be able to multiply rational expressions and divide rational expressions. And this is building off of when you multiply and divide polynomials. So, multiplying rational expressions. So just like fractions, if I have a fraction a over b times c over d, I multiply my numerators and get ac, and I multiply my denominators, b and d, and I get bd. It's the same if you have expressions. So I multiply my numerators, x times 4x squared would give me 4x cubed, and 2x minus 3 times 5 would be 5 times 2x minus 3. So if I want to multiply this, I'm going to multiply my numerators and denominators. But before I can do that, just like if I had a fraction, like if I had, for example, 4 over 7 times 14 over 2, I can say, okay, 4 and 2, these can simplify. I can say this is 2 and this is 1, and I can say 14 and 7, this is 2 and this is 1. And then I would multiply and get 4. And it would be much easier than multiplying 4 times 14, then 7 times 2, and simplifying. So we can do the same thing here. I can go through and simplify things. So let's start with the numbers. So 7 over 49, 7 goes into 49 7 times. So I can say this is going to be 1 if I divide both numerator and denominator by 7. I'm going to get 1 and 7. And 14 and 12 are both divisible by 2. If I divide this by 2, I get 7. And if I divide 12 by 2, I get 6. Now these numbers are easier to work with, and I could even simplify these 7s and say this is 1 and this is 1. Now my numbers are so much easier to multiply. Same thing with the variables. So I have x squared here and x here. X squared and x, this x is going to cancel with one of those to make this to the first. Okay, and then I can do my y's. So this is y, and this is y to the fourth. So this y becomes y to the third down here. And lastly, my z's, this is going to be 1, and this is going to become 2. This one cancels that. So when I do this on the numerator, 1 times 1, my coefficient is 1. This is x, and everything else is gone from the top. So I get 1x or just x. On the bottom, 6 times 1 is 6. This became z squared. And I have y to the third left on the bottom. Okay, so that's one way you can do it. You could have multiplied everything through and it would have been fine. If we had just simplified the numbers, we had said that this became 6, this became down to 1, that went down to 1, and this went down to 1 eventually. So if I had just done this, I could have done 1 on the top and done my variables, x squared, y, z, over 6. I still have an x on the bottom, a y to the fourth, and a z to the third. And then I could have gone through and simplified the way we did it before. So I have 2 and 1. It's bigger on the top, so I do 2 minus 1 is 1. I get x to the first on the top, and it goes away on the bottom. This one is 4, and this one is 1. 4 minus 1 is 3. It was bigger on the bottom, so I leave y to the third on the bottom. And this is 1, this is 3. Z to the third, and z to the first. 3 minus 1 is 2, bigger on the bottom, so my answer goes on the bottom. And that's another way you could have done it. Either way is fine. Okay, so with these, the first thing we always want to do is factor as much as we can. So b plus 3 can't factor any further, so I'm going to leave it. On the bottom, these both have a multiple of 4, so I pull out 4 and I have b minus 3. Okay, and then up top here, I want to multiply to 3 and add to negative 4, so it's going to be b minus 3 and b minus 1. Negative 1 and negative 3 multiply to a positive 3 and add to a negative 4. And on the bottom, I want to multiply to negative 30 and add to negative 7. So I'm going to do B, and let's see, 30, 15 and 2, 5 and 6, 10 and 3. That's what it's going to be because that's going to give me 7. So I want 10 to be negative because I want to end up negative, and I want 3 to be positive. So negative 10 and positive 3 multiply to negative 30 and add to a negative 7. Once I have this, I can start going through and canceling anything that's both in the top and the bottom. So this and this cancel, and then B minus 3's cancel, and then I just look and see what I have left. So on the top I have B minus 1, and on the bottom I have 4 times B minus 10, and that's my answer. Okay, so you guys give these a go. All right, example 2, the velocity that a spacecraft must have in order to escape Earth's gravitational pull is called the escape velocity. The escape velocity for a spacecraft leaving Earth is about 4,320 kilometers per hour. What is the speed in meters per second? So I want to switch this from kilometers per hour, so 40320 kilometers per hour. I'm going to write it like that. And I want to get it down to meters per second. So I have to get rid of kilometers and get to meters. So I'm going to put on the bottom kilometers, so that way the units kilometers cancel, and I want to go to meters, so that's going to go on the top. So I want to know how many meters are in 1 kilometer. Kilo means 1,000, so there's 1,000, that line is not supposed to be there, okay, 1,000 meters in a kilometer. So this is going to make my kilometers cancel. And I want to go from hours to seconds. So I want to get rid of hours, so I'm going to put hours on the top, and I want to go to seconds. So I want to know how many seconds are in an hour. Well, there's 60 seconds in a minute and 60 minutes in an hour. So there's going to be 60 times 60, 360, well, 3,600 seconds in 1 hour. Okay, and then I'm going to multiply. So my hours now cancel. So on the top I have this number times this number, and on the bottom I have 3,600 seconds, and on the top I'm going to have 40. Thank you. 40320, and adding on 3 zeros. And this is meters. And then I just simplify this part here. So I know those zeros cancel. And I'm going to figure out what this number divided by 36 is. So 403,200 divided by 36 is 11,200 meters per second is the speed that is required for the spacecraft to do what it's got to do. Okay. So you guys try. All right, so dividing rational function expressions, is very similar, except if you remember when we were talking about fractions, you switch the second fraction, you do the reciprocal, and you change it to multiplication. So it's going to be the same when I'm dividing rational expressions. I switch the second fraction, the numerator and denominator, find the reciprocal, and I change it to multiplication. And then I multiply and do the same things I was just doing. So if I want to divide this, first step is to think of it as multiplying by the reciprocal instead. And then I can go through and do the same thing I was doing before and cancel like terms and simplify. So 25 over 20, they're both divisible by 5. This one becomes 5. And this becomes 4. And 8 over 44, they're both divisible by 4. So this one up here becomes 2, and this one becomes 11. And 2 over 4, I can reduce that even more and say this is 1, and this is 2. So multiplying the numbers on the top, I get 5, and I still have that x squared up there. And on the bottom, I have 2 times 11 is 22, and I still have x cubed on the bottom. So the last step is to simplify the variables. So I get 5 and 22, I'm going to leave. And this one, x cubed and x squared, it's bigger on the bottom. I take 3 minus 2, I get 1, and I put it where it was bigger, which is the bottom. So 5 over 22x is the answer. Okay, you guys do this. Okay, so if I want to divide by this thing, I want to picture this. It's going to be the same thing as multiplying by the reciprocal. So if I want to find the reciprocal, I can picture it over 1. So this is going to be the same thing as 3x plus 9 over x squared times 1 over x plus 3. And I'm going to do this the same way I was doing previous problems. So I'm going to factor and cross out whatever I can. So on the top, this here, they're both divisible by 3. So this is 3 times x plus 3 when I factor out 3 over x squared times 1 over x plus 3. So now, here, I have x plus 3 on top and bottom. They cancel, and this becomes 3 over x squared. And now that's simplified. Okay, so we want to do the same thing here. Factor as much as we can. Y minus 6 doesn't factor on the bottom. These both have factor 2. So I pull out 2 and I get y plus 3. Change it to multiplication. I get y plus 3 over y plus 2. And then I'm canceling whatever I can. So y plus 3 is in top and bottom. They cancel. And I get y minus 6 over 2 times y plus 2. And that's as much as it simplifies, and we leave it like that. Okay, you guys try this one. And this one. Okay, so I want to simplify this one. Again, the same thing. I want to factor as much as I can. So here, this is x. I want to multiply to 18 and add to negative 9. So I'm going to do minus 6 and x minus 3. So they multiply to 18 and add to negative 9. And up here, this is x plus 5 and x minus 5. That gives me this. So I'm just going to rewrite all of this and also switch the second fraction. So I'm going to make it multiplication and switch the numerator and denominator. And then I'm going to go through and cancel whatever I can. So x minus 6 cancels, and x minus 5 cancels. And I'm left with 1, and there's nothing on top, so it's just 1 over x minus 3 times x plus 5. And that's that. You guys try this one. And that is the end of 11.4.